Scatter plots with no axes or labels can't be actually interpreted. That's why we need to add axes and labels. We'll discuss the margin convention, D3 axes, translating SVG group elements, accessing the range from scales, using class with D3 selections to disambiguate sibling elements, and adding axis labels using SVG text elements. I'm going to add X and Y axes and labels to this simple scatter plot that we developed earlier. I'll start by forking this one and calling it just scatter plot. And in viz.js, this is where we invoke our scatterplot component, which is defined here. This scatterplot component can be modified to also render axes. But if we render axes right away, there will be nothing displayed because they will be off the screen. Therefore, we first need to introduce the concept of a margin. See how those dots go right up to the edge? We need to introduce a bit of spacing or a margin on the top, right, bottom, and left so that these points don't go right up to the edge, but rather there's some space to put our axes. To make that happen, we're going to need to change the range of our scales. The X scale, for example, instead of starting at 0, should start at the left margin, and it should go to width minus right. There's a pretty strong convention in the D3 world to define a margin object with properties top, right, bottom, and left. And I'll set these all to be 10 pixels for now. Now that we have this margin object, we can refer to margin.left and margin.right. I'm pretty sure that worked. See, the circles don't go totally up against the edge, and we can test that by modifying the margin. If I set the left margin to be, let's say, 50 pixels, notice how everything gets sort of squished, and now that the left margin is 50, there's a 50 pixel gap on the left. Similarly, for Y, instead of going from height to 0, what we want to do is go from height minus margin dot bottom to margin dot top. Now, if we change the top margin to, let's say, 100, there's a space of 100 pixels on the top. And I'm just verifying that everything is set up by tweaking the right margin. Indeed, that works. If we tweak the bottom margin, there's space on the bottom, and the left margin we already checked. All right, that's how you can implement the margin convention of D3. Because these margin values are sort of arbitrary, it depends on the data set, how much space you want to leave, I'm going to make this configurable by adding it to this list of options. And then I'll remove this definition from here and then go over to viz.js where our scatter plot is invoked and pass the margin here as a configuration option. That way, if we want to change the margin, we don't have to change the scatterplot code itself. All right, now that we have some space where we can put axes, let's put the axes in that space. Over in scatterplot.js, we can modify this code to also render axes. Because this is already pretty, nice and simple and small, rather than add the code directly in here, I think what I'll do is create another component similar to scatterplot itself that's responsible for generating these axes. Then we can say selection.call axes and pass in an options object. The main thing that the axes will need in order to render are the scales. So I'll pass in X scale and Y scale. Then let's define axes. I will import axes from axes.js, which I will create as a new file that exports axes as a function that takes as input a selection and an option objects containing x scale and y scale. The next thing I'm going to do is import axis left from D3. Axis left is exported by the D3 axis package. This package contains some nice example code like this here, where it appends a group element, transforms it, and then just calls axis. An axis can be constructed like this, as an instance of d3.axisLeft passing in the scale. Let's apply this same pattern in our code. The first thing I'll implement is a group element. This element will serve as a container for our axis. In our code, selection is the top level SVG. So we could say selection.append G to get a group element. But remember, we're using unidirectional data flow as a pattern, so this function will be invoked over and over again. If we leave it like this, it will just continue to append new group elements, so we need to do something a little bit different. Instead, I'll say selection.selectAll G.data, an array containing a single element. .join G. This will create a single group element the first time this runs, and then it will reuse that existing group element on subsequent runs. The next thing I'll carry over from the D3 documentation is instantiation of an instance of axis left. I'll just paste that code, and because this is the left axis, I'll call this y axis. And because we imported axis left from D3, we don't need the D3 dot here. And instead of scale, we want to pass in y scale. Now all we need to do is link up this group element to this axis. In the documentation, it shows that you can just call .call on the group element, passing in the axis. So let's do that. .call y-axis. It looks like nothing happened, but that's just because the axis is off the screen. All that this axis knows about is the y scale, so it can't possibly know about the left margin. In the documentation, it applies a transform that translates this group element to the right by 30 pixels. This is our missing piece. What we need to do is translate this group element to the right by margin.left. And by the way, this translate syntax means move it to the right by 0 pixels, this is the x-coordinate, and move it down by 30 pixels. What we actually want to do is move it to the right. If I move it by, let's say, 50 pixels, you can see it show up. There's our axis. But instead of 50 pixels, really this should be margin.left. And to make that valid syntax, I need to change this to use backticks. Margin is not defined because we haven't passed it in. So I'll modify this axes function to accept margin as an option. And then over in scatterplot.js, we should call axes passing in the margin. That seems to have worked. Now we just need to tweak the margin itself in viz.js so that the left margin is big enough to show that axis. All right, there it is. Now we can see the y-axis. Now let's add an x-axis along the bottom. And because this variable is only used once, I think I'll simplify this code a bit by putting this directly in the dot call like that. This is almost exactly the same thing that we need for the x-axis. So I'll just copy paste that whole chunk. And then instead of axis left, this should be axis bottom. And instead of passing the y scale, we need to pass x scale. Axis bottom we need to import from D3. And we also need to fix this translate. This is not quite right. See, what happened here is that the axis appears at the top. So we need to translate it so that it goes down. And to do that, we should set the translate to go 0 in the x direction. But in the y direction, it should go down by, I think that should be height minus margin dot bottom. But wait a minute, this seems familiar. We already have that logic here when we define the range of the y scale. So maybe it might be cleaner to just pull that value out. That way, all we would need to do is pass in x scale and y scale to the axes. In axes.js, instead of passing in margin and height and all that, we can just access the range of the scales. Margin.left, for example, is the first value in the range of the x scale, which we can access by saying xscale.range at index 0. If you invoke .range and don't pass anything in, it will actually return the current value of the range, which remember is an array with two elements, the min and the max. Similarly, height minus margin.bottom is the first value in the range of the y scale. So we can access that with yscale.range at index 0. That appears to have worked. Again, we just need to tweak the margin so that the bottom margin is big enough to show that axis. And there it is. There's our x-axis. But what happened to our y-axis? This code that renders the axes has these two blocks, one for the y-axis, one for the x-axis. But they both use selection.selectAll G. That means that for the second one, it will pick up on the group element created by the first one, which we don't want. One way to solve this is to put different classes on these group elements. For example, we can say selection.selectAll G dot y-axis. And then after that gets created, we can add the class attribute of y-axis. And then we can use that same pattern for the x-axis as well. I'll just copy paste it and change y to x. And that worked. Now we have x and y axes. All right, that's how you can use D3 axis to create x and y axes on your scatter plot. Now that we've got these axes, we can tell what numbers the various positions correspond to, but we don't know what the axis means yet because there is no axis label. What I'd like to do next is introduce a piece of text that goes right on the edge that describes what this axis is. And in this case, I think it would say sepal length, or maybe sepal width. I don't know, because it's missing a label. Let me see, what would that label say? The x value corresponds to sepal length. And nowhere in here is a nice human readable value. I don't think we'd want to include the underscore. So what I'll do is I'll make a new field on the options object that we pass into our scatter plot called x-axis label, and I'll set that to be a string that will be a human readable version of sepal length. So I'll make it uppercase, remove the underscore, and then I'll do the same for y. Y-axis label is petal length. So now we're passing x-axis label and y-axis label into the scatter plot defined in scatterplot.js. Therefore, we need to also unpack those from this options object like this. Now that we have both of these in scope here, we can pass them into our axes function. And this axes function is defined in axes.js, and we can add these as options here as well. Now what we want to do is render SVG text elements, one for the y-axis label along one side, and then the other one for the x-axis label. The pattern will be quite similar to this, but instead of managing a single group element, we'll be managing a text element. I'll put these down at the bottom here, and I just pasted that logic for the y-axis group. And instead of being a group element, this will be a text element. And because we will have two of these, I still think it makes sense to have a class. I'll call this y-axis-label. All right, this code will create a singular text element. And lastly, we set the text content of the DOM node with .text on D3 selections. And this text should be the y-axis label string that we passed in. And might as well finish out the scaffolding of the DOM by doing the same thing for the x-axis label. Okay, I think that worked, but now we need to position these text elements, because see where they are? They're just right up in the corner and kind of off the screen. Ideally, the label for the y-axis would appear right here in the center vertically, and the label for the x-axis would appear right here in the center horizontally. And the y label, I would like to rotate it 90 degrees. I think the simpler of these two is the x label, so let's start with that. With text elements, I believe we can set x and y. Let's just try setting x to 100 and see if it moves. And I'll try setting y as well. Okay, there's sepal length. We want that to be down at the bottom and in the center. In fact, we want it at the same place as the x-axis, which is translated down by this value here, the first element of the y-scale range. So I can drop that right in for y, and now that puts the label right at the bottom. And see the alignment of the text? The baseline of the text is exactly on that line. So you know what? I think we might need to introduce another parameter that dictates the spacing. It's kind of like something that you can tweak along with the margin, maybe, to specify how far away from this line this label is going to be. But we really want to define how far the top of this is, not the bottom. To do that, we can use the alignment baseline attribute and set that to be hanging. See, now the text is hanging off the bottom of that line. And that should be separated from that line by a certain value, which we can add to the x position. I think I'll call it maybe x-axis label offset, and we can define that also as an option. And I think I'll give it a default value here of, let's say 20. All right, that looks good. Now the label is down there. All we have to do now is center it horizontally. And we can do that by setting the x position to be, well, we have access to x scale dot range. If we use the first element, that positions it on the left side, and if we use the second element, that positions it on the right side. We want to actually put it right in the middle between those two, and to do that, we can add these together and then divide by 2 to take the average position of the minimum and maximum values for the range. And that worked. It positioned it in the center. But the thing that is in the center is the left side of the text, not the center of the text. To fix that, we can use text anchor and set that to middle. Okay, that worked. We have successfully added an x-axis label. Now let's do the same for y. I can tell you right now, we're going to want to use text anchor middle to center it. And one of the first things I'm going to do is rotate it by 90 degrees because I think that will impact what x and y mean. To do that, we can set the transform attribute to be rotate 90 degrees. And there it is. But it looks like it's going down. I think I actually might want to rotate it by minus 90 degrees. And now we can't see it. Let's see what x and y do now. I'll set both of them to be 100 to start. And I still can't see the label. If I put x to be minus 100, now we can see it. There it is, petal length, right there. What's happening is that because of the rotation, x and y now have slightly different meanings because they kind of get applied after the rotation. So if we want to move this label to the right, we need to actually decrease x. Or no, sorry, that's not quite right. See, it moved down. If we want to move it down, we decrease x. And if we want to move it to the right, we increase y. Yeah, so x and y are kind of flipped around. But now we know y should actually position it close to the axis line using the same value by which we translate the y-axis, namely xscale.range at index 0. If I put that in there, we can see that the label perfectly aligns with that axis line. And again, we can introduce an offset, which we subtract from that. I'll call it y-axis label offset, and that can also have a default value of, let's say, 20. Okay, that worked, but it needs to be a little larger, let's say 30. Okay, there we go. Now the vertical position is still hard-coded. That's the last thing we need to fix here. It's hard-coded to minus 200. What we need is similar logic to how we centered the other one. So I'll copy that and paste it in here. And instead of referring to x scale, this should refer to y scale. It takes the midpoint of the y scale range by adding the minimum and maximum together, then dividing them by 2. And there it is. There's the label. As a last finishing touch here, we could make it the same font as those tick marks. And that font family is set by D3 axis to be sans serif. So we could just drop that as an attribute like this on the y-axis label. And notice the font has changed. This doesn't have serifs anymore, but the x-axis label still does. So I'll go ahead and apply that same change to the x-axis label. And I'll make a slight tweak to align things. And there it is. All right, that's how you can use D3 to put labels on your axes.